All right, everybody, let's go over this final review. First up, they're asking us to find the GCF and LCM of 40 and 64. So we have 40 and 64. We'll first find the GCF, greatest common factor. Bottom line is you want to start dividing these numbers by a number which divides both of them. 40 and 64, they can both be divided by what number? They can be divided by 2, right? Or you can just say that I can divide it by 8, right? So you'll have 5 here, and 8 8s are 64. Now, can you factor anything further from 5 and 8? Can you factor anything further from 5 and 8? No. So that means the greatest common factor is just equal to 8. Okay? That is the maximum I could have factored here. Now, if I want to find the LCM, we don't stop here. Okay, we keep going. 5 can be divided by 5, and 5 divided by 5 is 1. 8 cannot be fully divided by 5, so we leave 8 as it is. Then you can divide 8 by 8 itself. So 1 will stay as it is. 8 divided by 8 is 1. And whenever you end up with 1, 1 means you can stop there. And now to find your LCM, you will multiply all of these numbers. So it would be 8 times 5 times 8. Okay? So we can do 8 times 8 first, which is 64. 64 times 10 would have been 640. Half of that is 320. So your LCM is 320. We'll do one more example. Let's say we have 6 and 10. We want to find the greatest common factor. So think of a number that divides 6 and 10, 2. This will become 3. 6 divided by 2 is 3. 10 divided by 2 is 5. Ask yourself, can I factor anything further from 3 and 5? No. So that means our GCF is simply that number that we pulled out, which is 2. That is my GCF. To find LCM, we're going to keep going until we hit 1, 1. Now, 3 can be divided by 3. 3 divided by 3 is 1. 5 cannot be fully divided by 3, so we're going to leave it as 5. That 5 can be further divided by 5. 5 divided by 5 is 1, 1. So now we've ended up at 1, 1, means we're done. So to get your LCM, you will multiply all of these guys. 3 times 2 is 6. 6 times 5 is 30. So our LCM is equal to 30. Fairly straightforward. Next up, they're asking us to find square root of following numbers. Square root of 576 without a calculator. So what you want to do is you want to factor out 576 as much as you can. We can divide this by 2. Okay, so 4 divided by 2 gives me 2. Then that becomes 17, 8, 16, 288. Which can be further divided by 2, you get 144. Which can be further divided by 2, you get 72. Can be further divided by 2, you get 36. Can be further divided by 2, you get 18. Can be further divided by 2, you get 9. Which can be divided by 3, you get 3. Which can be divided by 3, you get 1. So you can say 576 is made up of how many 2's? 1, 2, 3, 4, 5, 6. So it's 2 to the power 6. And you have 3 squared. Okay. And whenever you have a square root, means your root is 2. Now, guys, any of the exponent that can be divided by the root will be able to bring it out. Any of the exponents. So 2 comes out and it'll be power inside over the root. 3 comes out, it'll be power inside over the root. So it's 2 to the power 3 times 3, which is 8 times 3, which is 24. Now, the next one is square root of 8100. Now, you should be able to recognize that, oh, this is just 81 times 100. Square root of 81 is 9, and square root of 100 is 10. So it's just 9 times 10, which is 90, right? So you should be able to see that, that way you can do these questions much faster. Next up, they want us to find cube root of 4076. Cube root of 4076. Again, we will factor out 4096, sorry. Divided by 2. This becomes 20, and then this will be 48. Divided by 2, you get 1024. Divided by 2, y12. Divided by 2, 256. Divided by 2, 128. Divided by 2, 64. Divided by 2, 32. Oh man, so many 2s. Divided by 2, 16. Divided by 2, 8. Divided by 2, 4. Divided by 2, 2. And finally divided by 2, and you get this. How many 2s are there? Way too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can write this as 2 to the power 12. 12 can be divided by 3, so we bring it out and its power inside over the root, which is 2 to the power 4. You should know 2 to the power 4 is 16. So cube root of 4096 is equal to 16. Okay. Next up, they've given you mixed radicals, and they want them to write they want you to write them as entire radical. So guys, this is how you do this. Pay attention. We want a radical over the whole thing. So that 3 is already inside the radical. What you do is, you know how when we bring stuff out of the radical, we do power inside divided by the root? When you put this 12 inside the radical, you'll do the opposite, which is you're going to take the power of 12, which is 1, and you're going to multiply it with the root, which is 2. So it will become 12 squared, which will be 144 times 3. Now you can punch it in your calculator. 144 times 3 gives you how much? $432. So that is square root of 432, and that is an entire radical. You see, everything is inside the radical. Okay. Let's have a look at the next one. We have 3 cube root of 7. You have cube root, 7 is already in there. Now the power of 3 is 1. When it goes inside, it'll be 1 times 3, which is 3 cube. 3 cube is 27 times 7. So punch in 27 times 7 in your calculator. 189. Okay, so that's cube root of 189. That's the entire radical. Let's try one more. If I give you 2, 5th root of 15. So you say we've got a 5th root, 15 is already inside. When 2 goes inside, power of 2 is 1. So when it goes in, it'll be 1 times 5, which is 5. 2 to the power 5 is 32. So what we need to do is 32 times 15. Punch it in your calculator. 480. So we got 5th root of 480. Next up, they're asking me to take this radical and write it in its simplest form. So what you will do is you'll divide 45 fully, or you can recognize that 45 is 9 times 5. What's square root of 9? 3. So that becomes 3 square root of 5. The other way you could have thought about it is that you can say, oh, if I factor this fully, you'll realize 45 is going to be 3 squared times 5. You have a root of 2. So that 3 squared comes out, and it'll be power inside over the root. And inside the square root, you just have a 5. So that's 3 to the power 1, which is 3 square root 5. See, same answer. Either or approach is okay. If I give you cube root of 128, again, we want to factor 128 fully. Divided by 2, you get 64. Divided by 2, you get 32. Divided by 2, you get 16. Divided by 2, you get 8. Divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get 1. 1, 2, 3, 4, 5, 6, 7. So 128 is 2 to the power 7. Now, can you divide 7 fully by 3? No. So we need to break up 7 so that at least we can take a portion of it out. Tell me, what's the largest multiple of 3 until 7? 6. So we're going to break it up as 2 to the power 6, and the leftover will be just 2 to the power 1, which is 2. Now 2 to the power 6 comes out, and it'll be power inside over the root. And on the inside, you're left with cube root of 2. 6 over 3 is 2. 2 squared is 4, so we have 4 cube root of 2. That's how you simplify it. Let's try another one. If I give you square root of 75. Okay, let's factor 75. You know you can divide it by 5, right? So you get what? 1, 5, which can be further divided by 5. You get 3, which can only be divided by itself. So you can say square root of 75 is square root of 5 squared times 3. Here's the square root. 5 squared comes out, and there'll be power inside over the root, and inside the square root is just 3. Or 5 square root 3. Another way you could have recognized this question was by recognizing that 75 is just 25 times 3. And square root of 25 is 5. So that's 5 square root 3. So either or approach is okay. This approach works well when the numbers are easy to break up. But sometimes the numbers are not going to be easy to break up. So then you have to use this method. Okay. Okay, cube root of 108. Let's take 108. Divided by 2. 54. Divided by 2. 27. Divided by 3. 9. Divided by 3. 3. Divided by 3. 1. So you can say cube root of 108 can be written as 3 cube times 2 square. Can't really do anything with 2 square because 2 cannot be divided by 3, but 3 cube can come out. And it'll be power inside over the root. And on the cube root, you just have a 4. 3 over 3 is 1. 3 to the power 1 is 3. So we have 3 cube root of 4. If they give you a bunch of radicals, let's say we have cube root of 30, square root of 20, fourth root of 18, and they say, and let's say another one is cube root of minus 30. Okay, this is more of a calculator type of a question, so don't worry about it. I'm not going to cover this. I'm going to mainly go over the logic stuff. Okay, let's go over exponents now. We have x to the power minus 3. Question is saying write these as a positive exponent. So we will just take the reciprocal, move it down, and the exponent will become positive. Next is 1 over d to the power minus 4. We'll take the reciprocal, move it to the top, and the exponent will become positive. It just changes its sign when you take the reciprocal. If I give you a over b to the power minus 2, take the reciprocal, it becomes b over a, and now your exponent becomes 2. Okay. Next up, guys, they've given us some exponents, and they want us to rewrite them as radicals. So this is how we do it, folks. Whatever the denominator of the power is, that becomes the root. And on the inside will be minus 8 raised to the power, the numerator. Now you should realize that minus to the power odd, a negative, if you raise it to an odd, it will stay negative. A negative, if you raise it to an even power, it becomes positive. So that's a negative to the odd, so it will stay negative, and then you will have 8 to the power 5. And whenever you have an odd root, guys, Whenever you have an odd root, the negative can be pulled out. So it will just be cube root of 8 to the power 5. Now 8 is 2 to the power 3. 8 is 2 to the power 3. So now what you have is minus cube root of 2 to the power 15. 15 can be divided by 3, so it'll come out and it'll become power inside over the root, which is minus 2 to the power 5. 2 to the power 5 is 32. So minus 32. Does that make sense? Take a moment on this one. Now on that end, I want to clarify a few basics. Guys, if you have negative 2 to the power 2, because your negative is being raised to an even power, it will become positive. So it will be same as positive 2 square, which is equal to positive 4. If I give you negative 2 to the power 3, now you have an odd power. So negative to the power odd number stays a negative. And it will just be negative 2 cube. And 2 cube is 8. So it's minus 8. If you ever see minus 2 square, will that be positive or negative? Negative. Why? Because the square is only applying to 2. The negative is already on the outside. So it's actually minus 4. People always get confused on this one. Remember, they did not put a bracket. The bracket would have meant that the square is being applied to negative and to the 2. When you don't see a bracket and you see a number written like this, that means the square is only being applied to 2. The negative is on the outside. Okay? Now, let's see. Okay, what will this be? Positive or negative? Negative. A negative to the odd is going to stay negative. So it will be minus 3 to the power 5. Pay attention, folks. Okay. If I give you square root of 5 cube, or actually, before that, let's do a couple more exponent to radical. If I give you 48 to the power 1 over 2. So when you write this as a radical, it's a square root, and you have 48. And you got to simplify this. Okay, if you factor 48 fully, divided by 2, you get 24. Divided by 2, you get 12. Divided by 2, you get 6. Divided by 2, you get 3. And divided by 3, you get 1. So that will become 2 to the power 4 times 3. So 2 to the power 4 comes out, and it'll be power inside over the root. And inside the square root, you just have that. 2 square is 4. That becomes 4 square root 3. If I give you 25 to the power 3 over 4, okay, it will be 4th root of 25 to the power 3. Simple. I give you 7 to the power minus 1 over 3. You will first move it to the bottom, so the power becomes positive. And now at the bottom, you have a cube root of 7 to the power 1, which is just cube root of 7. Next up, if I give you, let's say, a radical, and I ask you to write this as the exponent. Okay, how do we do it? So we have 4. What's the power inside? 1. So power inside divided by root. So cube root of 4 is just 4 to the power 1 over 3. If I give you square root of 5 whole cube, you can move the 3 inside now. And your root is 2. So it will be 5 to the power inside over the root. If I give you 4th root of x cubed, it will be x to the power 3 over 4. Fairly straightforward. If I give you y cubed times y squared, okay, you just add up the exponents, 3 plus 2, which is y to the power 5. If I give you a to the power 6 over a to the power 2, See, my power at the top is bigger. So we do power of the top minus power of the bottom, which is a to the power 4. If I give you d to the power 7 whole square, in this case, you multiply them. So it's d to the power 7 times 2, which is d to the power 14. Next, they're asking us to evaluate 3 to the power minus 2. Well, let's turn the power to a positive number. So 1 over 3 to the power 2. 3 to the power 2 is 9, so it's 1 over 9. Simple. If I give you 4 to the power minus 3, take the reciprocal because I want to turn the power into a positive number. So it's 1 over 4 to the power 3. Simple. They've given us 27 to the power 2 over 3. Okay, anytime you see exponents, which are fractions, I want you to focus on the denominator. Denominator is 3. Now you got to ask yourself, hey, you got to say, hey, can I write 27 as a power of 3? Okay, and for that, guys, you need to know your cubes. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. That means cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. So you should recognize that 27 can be written as 3 to the power 3. What happens next? It's to the power 2 over 3. Now you multiply the powers. So it's 3 to the power 3 times 2 over 3. This cancels out. So you have 3 squared, which is equal to 9. Okay? If I give you 27 to the power minus 1 over 3. Okay, take the reciprocal, you move it to the bottom, it becomes 27 to the power 1 over 3. And 27 can be written as 3 to the power 3. What happens? The denominator cancels with that. So your answer is just 1 over 3. If I give you m to the power minus 7 times m to the power 3, whenever they're multiplying, you can add the powers right there, or you could have taken the reciprocal of the negative power. Either or approach is okay. You can do that. Move it to the bottom. And then you should recognize I have bigger power at the bottom. So we will do power of the bottom minus power of the top, which will be 1 over m to the power 4. If I give you a to the power 3 over a to the power minus 8, I'll move a to the power minus 8 to the top, so it becomes a to the power positive 8, and then you add the exponents. So you have a to the power 11. If I give you x squared times y to the power minus 3, all raised to the power 4, FOIL it. So x to the power 2 times 4 times y to the power minus 3 times 4. That gives me x to the power 8 times y to the power minus 12, which is x to the power 8 over y to the power positive 12. Next up, we have a cube b times a to the power minus 1 times b to the power 4. So let's multiply the a, guys. So you have a cubed times a to the power minus 1. Either you can say I'll move a to the power minus 1 to the bottom, so it'll become a to the power positive 1. The b's are both at the top and both are positive, so you can add the powers, 1 plus 4. And now you will do power of the top minus power of the bottom for a. So that will be a to the power 2 times b to the power 5. Simple. Does that make sense? Good. If I give you x squared y over x cubed y to the power minus 2. Okay, let's move the y to the power minus 2 to the top first. So it becomes y to the power positive 2, and x cubed is at the bottom. Let's compare the x's. I have more bigger power of x at the bottom. So we'll do power of the bottom minus power of the top. For the y's at the top, we will just add their powers, 1 plus 2. So we get y cubed over x squared. Fairly simple. If I give you m squared, n to the power minus 4, all to the power minus 2, FOIL them. So m to the power 2 times minus 2 times n to the power minus 4 times minus 2. So we have m to the power minus 4 times n to the power 8. Move the m down. So it will become m to the power positive 4. If I give you g to the power 2 over 3 times h to the power minus 3 over 4 times g to the power 1 over 4 times h to the power 1 over 2, you will add the powers of the g terms because they're multiplying. So you have 2 over 3 plus 1 over 4. And you would add the powers of the h terms. So that would be minus 3 over 4 plus 1 over 2. Clearly, we got to get the common denominator. The common denominator of 3 and 4 is 12. So we got to multiply this by 4 and this by 4. And we got to multiply this by 3 and the numerator by 3. So I get g to the power 8 over 8. Sorry, 8 over 12 plus 3 over 12, or 8 plus 3 all over 12. For h also, we got to get the common denominator. So got to times this by 2 and this by 2. So we get h to the power minus 3 plus 2 all over 4. So that gives me g to the power 11 over 12 times h to the power minus 1 over 4. So I'll move the h term to the bottom. So it'll be g to the power 11 over 12 over h to the power 1 over h to the power 1 over 4. If I give you x to the power minus 2 over 5, all raised to the power 2 over 3. When you FOIL them, we'll have to multiply those powers. So that gives you x to the power minus 4 over 15. We will take the reciprocal, so the power becomes positive. So 1 over x to the power 4 over 15. Fairly simple. On the second one, we have 4x to the power 3 over 4 divided by 9x cubed, all to the power minus 1 over 2. First thing, we will flip them so the power becomes positive. So it will be 9x cubed over 4x to the power 3 over 4, all raised to the power 1 over 2. Next, I'll realize that 9 can be written as 3 squared. And 4 can be written as 2 squared. And on the inside, the power at the top is bigger. So we'll do power of the top minus power of the bottom, all to the power 1 over 2. So you got to get the common denominator on the power of x. Between 1 and 4 is 4. So you got to multiply this one by 4 and the numerator by 4. So that becomes 3 squared times x to the power 12 minus 3, which is 9 over 4, over 2 to the power 2, all raised to the power 1 over 2. FOIL them. So it'll be 3 to the power 2 times 1 over 2 times x to the power 9 over 4 times 1 over 2 divided by 2 squared times 1 over 2. So this cancels with this. And we have 3 x to the power 9 over 8 over simply 2. Does that make sense? Take a moment on this, folks. Okay, Folks, we're moving on to trig here. They've given us a right triangle. This angle is 48 degrees. This side is given to us, and they're asking us to find this missing side. So step number one should be labeling the sides. This is 90 degrees, so right across is our hypotenuse. This is the angle given to me, right across is opposite, and this side will be adjacent. On this question, they have given you h, and they're asking you to find O. So we want to use a formula which involves O and h. So tells me that we have to use sine. So sine 48 will be equal to opposite, which is k, opposite over hypotenuse. And your opposite is k, and your hypotenuse is 5.9. Okay, guys? So sine 48 is equal to k divided by 5.9, and you cross multiply to solve for k. So your k will be 5.9 times sine 48. Okay, punch it in, and you should get your answer. I'll let you do the punching it in part at your end. Just make sure your calculator is in degree mode. Okay, couple more questions here. This is 90 degrees, right across is my hypotenuse. This is the angle that they're asking me to find. Let's call that angle theta. So that would have been opposite, and this is your adjacent. So on here, they've given you A and H. So we have to use cos. So we'll say cos theta is adjacent over hypotenuse. My adjacent is 3 and hypotenuse is 10. So cos theta is equal to 3 over 10, which means theta will be inverse cos of 3 over 10. Make sure you put brackets. So second cos or shift cos, depending on which calculator you have, and you should be able to get your answer. Make sure your calculator is in degree mode, not radian mode. Okay, over here, same thing, 90 degrees, right across is hypotenuse. This is the angle given to me, that's my opposite, and adjacent is given to me. So we're dealing with O and A there. A is given to me, O is what we need to find, so we have to use TOA, tan. Tan 63 is opposite over adjacent. Your opposite is what we're trying to find, and our adjacent is 1.9. You'll cross multiply that. 1.9 times tan 63 will be your k value. What would that be equal to? 1.9 times tan 63. Anyways, you punch it in, get your answer. These are very similar questions. Now, whenever they say solve the triangle, means now they want you to find all the sides and all the angles. So there will be multiple steps involved there. Steps are the same. This is 90 degrees. Right across is hypotenuse. This is the angle given to me. Opposite to it is opposite. And this is your adjacent. So we know H. Let's find O first. So we need to use something which uses O and H. That would be sine. So sine 27 will be opposite over hypotenuse, which is 4.4. Cross multiply. So we get opposite is 4.4 times sine 27. Guys, 4.4 times sine 27 is how much? Punch it in, you get your answer. If you want to find adjacent, then you say, okay, H is given to me, and now I got to find adjacent. So now we have to use cos. We'll say cos 27 is adjacent over hypotenuse. And adjacent is what we're looking for. Hypotenuse is 4.4. So again, you would cross multiply. So 4.4 times cos 27 will give you your adjacent. Fairly simple. Okay. Over here, they're asking us to expand and simplify. What we have is 9 plus m times 9 plus m. You can FOIL it, how we normally do it, or you can recognize that this is essentially 9 plus m whole square. So we can use our a plus b whole square formula there. Remember, a plus b whole square is a square plus b square plus 2ab. I also want you to remember a minus b whole square, which is a square plus b square minus 2ab. You should also know your difference of square, which is a square minus b square equals to a plus b times a minus b. Remember those three formulas, folks? They're going to come in handy. So what we have there is 9 plus m whole square, which is our a plus b whole square formula. So that will be a square, which is 9 square, plus b square, which is this, minus 2 times a times b. So that becomes 81 plus m square minus 18m. You should always write the square term first, then the combined term, and then the constant at the end. That's how you expand this part. Moving on to the next question. 3a minus 5 times 2a minus 3. We'll take 3a, multiply with 2a. 3 times 2 is 6, a times a is a squared. And you take 3a, multiply with minus 3. 3 times minus 3 is minus 9 times a. And you take minus 5, multiply with 2a, that's minus 10a. Then you take minus 5, multiply with minus 3, that'll give you 15. So we have 6a squared minus 19a plus 15. Fairly simple. Same over here. We'll do 2n times 5n. 2 times 5 is 10. N times n is n squared. 2n times minus 4p. 2 times minus 4 is minus 8. np. 3p times 5n will be 15pn or np. p and np is the same. So let's just call it np. Then 3p times minus 4p, that will be minus 12p squared. So that will be 10n squared minus 8 plus 15 is 7 np minus 12p squared. Does that make sense? You take d part, you take w, multiply with this, that gives you minus 2w cubed. And you take w, multiply with this, you get 7w squared. And you take w, multiplied with this, you get minus 8w. Then you take 4, multiply with this, you get minus 8w squared. You take the same 4, multiply with this, you get 28w. Take the same 4, multiply with minus 8, you get minus 32. Now you combine all the like terms. We have minus 2w cubed. 7w squared minus 8w squared will be just minus w squared. Minus 8w plus 28w will be plus 20w minus 32. Now, if you get something like this, you're going to first pick 4, multiply it with this, then take 4, multiply it with this, then take 4, multiply it with this. Then you move on to the next guy. You take 3x, multiply with this, 3x, multiply with this, 3x, multiply with this. Then you take minus 2x squared, multiply with this, minus 2x squared, multiply with this, minus 2x squared, multiply with this. Then you combine like terms. It'll be long, but stay patient, okay? When you look at something like this, that should remind you of a minus b whole square formula, which is a squared plus b squared minus 2ab, where your a is now 3x and your b is 2. So when you FOIL that, it will be a squared, which is 3x whole square, plus b squared minus 2 times a times b. So that's 9x squared plus 4. 2 times 3 is 6. 6 times 2 is 12 minus 12x. 9x squared minus 12x plus 4. Okay. Next up, they're asking you to factor some of these terms. Okay, so they've given you this. I want you to first look at the numbers. I see 14, 28, 21, 14, 28, 21. They can all be factored by what number? What do they have in common? 14, 28, 21, 7. Good. We can factor 7 out. Then look at the a's, the power of a's, a cubed. And there is no a in the middle term, so we cannot factor out a. Let's look at b. We have b squared, b cubed, but there's no b on the third one. And c, there's no c on the first one. So the only thing that I can factor is 7 here. That's my greatest common factor. What's left on the inside? 2a cubed b squared minus 4 b cubed c squared plus 3 a squared c cubed. Okay, and the greatest common factor is 7 because that's the maximum that we can factor. Now they've given us quadratic equations. We want to factor them. Very simple. We'll take the number in front, multiply with the last number. 1 times minus 12 gives me minus 12. We want to find two numbers. When you multiply, you get minus 12. When you add them, you get this middle number, which is minus 1. That'll be minus 4 and 3. Minus 4 times 3 is minus 12. And minus 4 plus 3 is minus 1. And the number in front of n squared is 1. So we'll just work with those numbers. We'll say the first factor is n minus 4. And the second one is n plus 3. Simple. Done. Factored. On C, I see we got 36r squared minus 64m squared. I recognize that's like difference of square because 36 can be written as 6 squared and 64 can be written as 8 squared. So we can rewrite this as 6r whole square minus 8m whole square. So it will be a plus b times a minus b. So it will be 6r plus 8m times 6r minus 8m. At this point, I realize, well, 6 and 8 also have 2 in common. So I can factor the 2 out of this. And I'll have 3r plus 4m. I can also factor the 2 out of the second one, which will leave me with 3r minus 4m. And 2 times 2 will become 4. So we have 4 times 3r plus 4m times 3r minus 4m. There we go. Okay. On this one, we'll do 6 times minus 18. Okay. Now, I know 6 times minus 18 becomes a big number, right? So there's another way to think about it. Okay, what are the factors of 6? 2 and 3, other than 1, right? And what about this 18? 2, 3, and 3. Because 2 times 9 is 18 if you fully factor it. 2 times 3 and another 3. Now we want to use a combination of these numbers to get 23. See what combination is possible. Okay, so let's see. Let's say if I do 3 times 3 and I do the rest of these guys. 3 times 3 is 9. 3 times 2 is 6. 6 times 2 is 12. 12 and 9? No, 12 and 9 doesn't give me 23. Okay, we have to try some other combination. So what if we do 3 times 3 times 3 and that's going to be 27 and 4. That's exactly what it is. Yeah, look at that. 27 and 2 times 2 is 4. 27 minus 4 gives me 23. Yes, that's the one. So 27 and 4. See? 27 and 4. So my numbers are 27 and minus 4. But remember, there's a 6 in front, so we must divide these by 6. Whenever there's a number other than 1 in front, we must divide them. 27 and 6 can be divided by 3. 27 divided by 3 is 9. 6 divided by 3 is 2. 4 and 6 can be divided by 2. So minus 4 divided by 2 is minus 2. 6 divided by 2 is 3. We have 9 over 2 and minus 2 over 3. The 2 will go in front of m. So it will become 2m plus 9. 3 will go in front of m. It will become 3m. And you're left with minus 2. That's a fact. As you can see, this is a bit of a challenging question. Okay, let's try another one. Minus 24m square n minus 6mn square. I first look at the numbers. I realize we can factor out minus 6. And then I look at m square and m. You can always factor out the lower power. So we will factor only 1m. I have n and n square. We will factor only lower power, which is just n. So what's left out of the first one? Okay, if you factor -6, this will just be 4. From m square, I took 1m out, so there's 1m left. And you took that n out. Because you factor a negative, all the signs are going to change, so this becomes plus. I took 6 out, m out. From n square, I took n out, so I'm left with only n. So it's -6mn times 4m plus n. Simple. Okay, let's have a look at h. The number in front of x squared is 1. 1 times 12 will give me 12. We want to think of two numbers. When you multiply, you get 12. When you add them, you get 8. That's easy, 6 and 2. Number in front of x squared is 1, so that will just be x plus 6 and x plus 2. Simple. For this, it'll be 1 times 27, which gives me 27. We need to think of two numbers. When you multiply, you get 27. When you add them, you get -12. Some combination of 9 and 3, but because the sum needs to be -12, so it'll be -9 and -3. So it will be u minus 9 and u minus 3. Simple. That's how you will factor that. When you see this, I realize 16 can be written as 4 square, so that's 4b whole square. 49 is 7 square, so that's a square minus b square, which is a plus b times a minus b. Same over here. 9 can be written as 3 square, so it's 3y whole square minus 5x whole square. So it will be 3y plus 5x times 3y minus 5x. Simple. X squared minus 5x, factor the x out, and you get x times x minus 5. Okay, this is another tricky one. 16 is 4 squared, so that will become 4. Oh, that's x to the power 4, which you can write as x squared square. So that'll become 4x squared whole square minus 1 square. So that'll be a plus b, which is this, times a minus b. And we don't really have a formula for a squared plus b squared. It's only a squared minus b squared. So, but this can be factored further. How? Because we can rewrite that 4 can be written as 2 square. So that will be 2x whole square minus 1 square. So we have another version of a square minus b square. So that will become 4x squared plus 1. Now the other guy becomes a plus b times a minus b. That's a tricky one, folks. Make a note of this. They've given us a bunch of graphs and a table, and they're asking us if it's a function or not. For graphs, it's easy. You can do a vertical line test. If it only cuts at one point, it's a function. See, you can draw any vertical line. It's only cutting at one point, so this is a function. Over here, if you drew a vertical line, it's cutting at 3 points, so it's not a function. When a table is given to you, you want to make sure no x value repeats. So we had 8. 8 doesn't repeat anywhere. 7 doesn't repeat anywhere. 6 doesn't repeat. 5 doesn't repeat. 4 doesn't repeat. No x values repeat. Therefore, it is a function. If any x value was repeating, then you would say it's not a function. Simple. Again, over here, you see the x value repeats here straight away. It's not a function. Now, when they give you something like this, guys, you should always try to make points out of those. When you see a line going from -2, right? See over here, you have a line going from -2 to 1. That means the point is -2, 1. And then you have a line going from 1 to 2, so the point is 1, 2. And then you have 5 to -4, so you have a point 5, -4. And then -3 to -2, so -3, -2. Did any x value repeat? Therefore, this is a function. No x value is repeated. Therefore, this is a function. Okay, pretty simple. But if you look at this other one, f, you can see there's a point which goes from 5 to 4. There's another point which goes from 5 to 1, right? One is going from 5 to 4, so that point is 5, 4. And then one line is going from 5 to 1, so that point is 5, 1. Clearly, x value is repeating, therefore it's not a function. When they give you points like this, see, one is repeating, not a function. No x values are repeating over here, so therefore it is a function. Over here, graphs are given to us. You can do vertical line anywhere. It is a function. It's only intersecting at one point. But if you do it here, it's intersecting at 2 points. It's not a function. Or even over here, you can do vertical line anywhere. It's only intersecting at 1 point. So this is also a function. Okay, that's how you determine when something is a function or not. Now they're asking you to write the domain and range. They've given you this. So simple. Your domain is all the x values, right from smaller to larger. So 1, 2, 3, 4. Your range is all the y values. 3, 5, 7. Don't repeat 7. You just say 3, 5, 7. Now on this B graph, it's a continuous graph. Going from this point, it's shaded to this point. So for the domain, okay, you can see the leftmost x value is -3 and the rightmost x value is 9. So x is going from -3 to 9. That's one way of writing it. Or you could have said, you make this interval notation or set notation, I guess. And you say domain is for x, and over here x is between -3 and 9, where x is all real numbers. That's another way you can write the domain. Or you can describe it in words. You can say x is all real numbers between -3 and 9, where both -3 and 9 are included. Okay. For this, you would just say my domain is -2, -1, and 6. Don't repeat it. And your range is, you go from the smallest, which is -2, 3, 4, 7. From that. They've given you this discrete graph. Okay, so identify what's this number. That's 0. That's -1. That's -2. That's 1, 2, 3, 4. That's y value of 1, 2, 3, 4. -1. Okay. So as you can see for the domain, let's write the domain first. So discrete graph, what's the domain? Leftmost, we have x value of -2. Then we have 1. Then we have 3 and 4 on this graph. For the range, you would put the y values. So we have -1, -2, -3, and -3.5. And then this one, which is -0.5. And then this one, which is 1.5. This is 2.5. And this is 4. Simple stuff. Then they've given you these graphs. So let's have a look at this graph right here. Domain is for x values. It's going from -5, but there's an open hole, so it's not part of the solution. So you put a curly bracket, and it's going till 4. Sorry, x value of 0. And you would put that as a closed bracket. To write it as the other notation, you would have said domain is for x, and x is going from -5, is greater than -5, but it's less than or equal to 0, where x is all real numbers. Okay. For the range, You're going from y value of -4, where -4 is now included, to y value of 5, which is not included. Or you can say ranges for y, where you're going from -4 to 5, where y is all real numbers. Does that make sense? Good. On this graph, your x values are going from -5, and the rightmost x value is at 3, and both of them are included. In the other notation, you would have said it's for x, and x values are going from -5 to 3. Both are included, where x is all real numbers. For the range, you're going from y value of -3 to 3, where both of them are included. So close bracket from -3 to 3. Or you can write your range as ranges for y, where it's between -3 and 3, where y is all real numbers. And you should be able to do the rest of the graphs. Okay, I'll pick one of them here, one of these guys. Okay, let's start with A. Is going, see, it has an arrow, means it's going to go to the left forever. It's going to go for domain, it's going to go till -infinity. And that's not a defined number, so you put open bracket. But the rightmost x value is 0. That's your domain. For the range, the smallest y value is -3, and it's going up forever. So it's going from -3, which is included, to infinity. Okay? For the next one, for this one, your x values are going from -infinity to +infinity. So your domain is from -infinity to +infinity. Now let's have a closer look at the range, okay? Let's see what's it doing for the y. Okay, guys, this one is actually a bit tricky. Okay, I want to make sure that they haven't drawn an asymptote there. I don't think they've drawn an asymptote. It's still curling down. So that means it's going to eventually go all the way down. And this will go eventually all the way up. So same, going from -infinity to +infinity. Okay. But they should have clarified that part. Okay. Next is slopes. They've given us a bunch of these equations, and they're asking us to find the slope. The first equation is in x-intercept form, which is mx plus b. Now look at that equation. Tell me what's the slope? -2. That's the number in front of x. The second equation is in slope point form, which is like y minus y1 equals m times x minus x1. What's your slope? That number right there, 3. Over here, you should first rewrite it by bringing x in front. And it's in the form of mx plus b, where your slope is -5. Y equals to x means you can rewrite it as y equals to 1x. So the number in front of x is 1. So slope is 1. Okay? So you should be able to identify the slope from any form of equation. So 23 says a line has a slope of 3/5. What's the slope of a line that is parallel? Parallel line will have the same slope. Right? Parallel lines have same slope. So it'll be 3/5. Then they're saying, what's the slope of perpendicular? So you would say perpendicular line, you will switch the number and you will switch the sign. Switch the numerator and the denominator and switch the sign. So -5/3, which you can call as negative reciprocal. Again, they say slope of a line has a slope of -4. What's the slope of a parallel line? Will be the same, so minus 4. What about the slope of the perpendicular line? Well, you should say that minus 4 can be thought of as minus 4 over 1. So switch the sign, it becomes positive, and switch the numerator with the denominator, positive 1 over 4. Okay? Now they're asking us to get the slope from these given graphs. Okay, we all know the slope. You can think of it as a rise over run, or remember at the bottom, we always put the number which is over. At the top, we always put the number which is up or down. So this is 1 point given to me. This is another point. How much over did I go? 1, 2, 3, 4, 4 over. So at the bottom, I put 4. And then I went how much down? You always go from left to right. 1, 2, 3, 4, 5, 6. 6 down. So minus 6. You simplify it and it becomes minus 3 over 2. That's the slope of A graph. Okay. Now let's get the slope of the other one. B. Same thing. They've given you this point right here. Give me a moment. They've given you this point, and that's the other point. How much over did you go? 1, 2, 3, 4, 5, 6, 7. Over value goes in the denominator. And how much up? 1, 2, 3, 4. 4 up. So positive 4. Your slope is 4 over 7. Next up, they're asking us to find the slope of a line that passes through these 2 points. So in that case, we always find the slope by doing change in y over change in x. Okay? So we will find the slope by doing change in y over change in x. But whenever they give you points, we do y2 minus y1 over x2 minus x1. So think of this point, minus 6, 8 as x1 and y1. And think of, so this is x1, this is y1. And think of minus 1 and minus 2 as x2 and y2. So the slope will be minus 2 minus 8 over minus 1 minus minus 6. Be careful about the sign. So the top is minus 10 and the bottom is minus 1 plus 6, which is 5. 10 divided by 5 is 2. So your slope is minus 2. Okay? So whenever they give you the points, to get the slope, you will do y2 minus y1 over x2 minus x1. Next up, they've given us a point minus 3, 7 and 5, minus 5. So let's call this x1. Let's call this y1. Let's call this x2. Let's call this y2. And our slope will be y2 minus y1 over x2 minus x1. So that would be minus 5 minus 7 divided by 5 minus minus 3. Minus 5 minus 7 is going to be minus 12. 5 plus 3 is going to be 8. Both of those numbers can be divided by 4. Our slope is minus 3 over 2. Simple stuff. Okay, next up, the question says the equation of 2 lines are given to you. Are these 2 lines parallel, perpendicular, or neither? So I say, okay, well, let me find the slope of the first equation. That's minus 3. And the y-intercept, that is 6. What's the slope of the second line? 1 over 3. And the y-intercept is minus 20. Okay. You can see that their slopes are actually negative reciprocal. See? If you look at minus 3, the sign has been switched. Minus 3 can be thought of as minus 3 over 1. The sign got switched, became positive, and the numerator and the denominator swapped. So it's negative reciprocal. Therefore, these 2 lines are perpendicular to each other because their slopes are negative reciprocal of each other. Next up, they're saying draw a line segment that has a slope of -3/4. So we need a slope of -3/4. And it goes through a point 2, -3. Okay, so x is 2, y is -3. So x is 2 here, y is -3. 1, 2, 3. Right here. Here's my first point. My slope is -3/4. That means I got to go 4 over to the right and 3 down. 4 over to the right from that point. 1, 2, 3, 4. And 3 down. 1, 2, 3. Here's my second point. You're going to take your ruler and you're going to connect those 2 points. Obviously, I'm doing it with hand. You're going to draw it with a ruler where this line will go through both of these points. Does that make sense? Fairly simple. Now they're saying state whether the following represents a linear relation. Well, there's many ways of knowing if an equation is linear. Firstly, if you see something in the form of mx plus b, that is linear. Or anything in the form of these other forms, those are also linear equations, right? Or if you have something like ax plus by plus c equals to 0, these are all different linear forms. But the best way to think about it is, okay, if the power of the x is 1 or 0, exponent of x, or the power of y is 1 or 0, is linear. Anything higher will be quadratic or cubic. Okay, look at that. Power of x is 1, power of y is 1, so this is definitely linear. When they give me a bunch of points, how do I know if it's linear? Well, let's see. What's the change in x happening? When you go from 2 to 4, you went up by 2. 4 to 6 went up by 2. 6 to 8 went up by 2. Okay, what about the change in y? 7 to 10 went up by 3. 10 to 13 went up by 3. 13 to 16 went up by 3. You can find the slope from any interval. Our slope is change in y over change in x. You can pick any interval, your slope is 3 over 2. Because your change in y everywhere is plus 3. Your change in x everywhere is plus 2. So your slope, you can pick any 2 points and you will get a slope of 3 over 2, which means you have a constant slope, and linear graphs have a constant slope. So this is a linear relation. Only linear relations have constant slope all throughout. Now, if they ever give you x equals to -4, you got to be able to visualize it. That means at x equals to -4, your x values are -4 at all times. So you realize that's going to be a vertical line, which is a straight line. So it is linear. A straight line is a linear line. If they ever gave you y equals to 2, that would also be linear. Why? Because that would mean y values 2 at all times. So that would be a straight horizontal line. You should know the slope of a vertical line is undefined. You should know the slope of a horizontal line is 0. Okay? Keep that in mind. Over here, they've given you a graph and they're asking you to find the x-intercept and the y-intercept. X-intercept is where it cuts the x-axis. This graph is cutting the x-axis here, which is at x value of 3. So the x-intercept is at 3. It's cutting the y-axis at 1, 2, 3, 4, 5, 6, 7-ish. Yeah, at 7. So you will say your y-intercept is at 7. Hey guys, now they've given you a g of x equation, which is 2x minus 4, and they're asking you to find g of minus 1. G of minus 1 just means that for x, you're going to put in minus 1. So in this equation, anywhere you see x, you're going to put minus 1 in that place. So that becomes minus 2 minus 4, which is minus 6. That's your A part. In the B part, they're saying that g of x is equal to 2, and they want you to solve for x. Okay, look, this is the equation given to me. G of x is 2, so put 2 for g of x. That is equal to 2x minus 4. Move the minus 4 to the other side. So 2 plus 4 will become 6. That is equal to 2x. Divide both sides by 2. X will be 6 over 2, which is equal to 3. Okay, now guys, they've given you equations and they're asking you to find the x and y intercept. You should recognize, okay, This is where the x-intercept is, right? This is the x-intercept. At the x-intercept, y value is equal to 0. This is your y-intercept. At the y-intercept, x value is equal to 0. So to get the x-intercept, you plug in 0 for y. To get the y-intercept, you plug in 0 for x. So they've given you this equation. So you say to find the y-intercept, I will plug in x equals to 0. So in that equation, if you plug in 0 for x, it becomes this. Which means minus 5y is equal to 20. Divide both sides by minus 5. Y is equal to minus 4. To find the x-intercept, now we will plug in y equals to 0. So over here, you will plug in 0 for y. So that becomes 2x minus 5 times 0 is equal to 20. Which means 2x is equal to 20. X is equal to 10. So guys, our x-intercept is 10 and our y-intercept is minus 4. Now they're asking us to graph the following equations. So this is easy. The slope is minus 3, which you can think of it as minus 3 over 1. And the y-intercept is minus 2. So we make the y-intercept at minus 2, which will be here. And then we need to go 1 over and 3 down. So we go 1 over and 3 down. 1, 2, 3. That's my second point. Take a ruler and draw a line that goes through those 2 points. So this is what the graph will look like. On something like this, isolate your y, move the 2x to the other side, becomes minus 2x plus 3. Your slope is minus 2 over 1, and your y-intercept is 3. The y-intercept is 3, and the bottom number tells you how much over you go. The top number, if negative, you go down. So we go 1 over and 2 down. 1 over, 2 down. Here's the second point. Take your ruler, draw a line going through those 2 points. That's your graph. Something like this again, move, isolate your y, 4x goes to the other side, becomes minus 4x, minus 24 becomes 24. Then we divide everything by 3. So we get y is equal to minus 4 over 3x plus 8. So our slope is minus 4 over 3 and our b value is 8. So b value is 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we go 3 over and 4 down. So 1, 2, 3, 1, 2, 3, 4. Take your ruler, join those 2 points. Simple. All of those are quite similar. Okay. Now they're saying write an equation of a line that has a slope of minus 4 and a y-intercept of 9. So slope is minus 4, y-intercept is 9. That's easy. We'll just say y is equal to mx plus b, which means it's minus 4x plus 9. Then they're saying write an equation of a line that has a slope of minus 2 over 3. So slope is minus 2 over 3. And it passes through a point of minus 2 comma 5. Well, okay, let's do this. Y is equal to mx plus b, right? We can say my slope is minus 2 over 3x plus b, but we don't know the b value. To get the b value, you will plug in those points for x and y. So you will plug in 5 for y, and you will plug in minus 2 for x. So that becomes 5 is equal to 4 over 3 plus b. So your b value will be 5 minus 4 over 3. Get the common denominator. So times this by 3, times that by 3. 15 minus 4, which is 11 over 3. So now you have your equation. Y is equal to minus 2 over 3x plus 11 over 3. We had to do all this work because we wanted to write this as a slope-intercept form. The question did not say that, but they could have very well said, write the equation in slope-intercept form. But you should recognize that if the question doesn't say which form I need to use, then there's actually a much easier way of writing this equation if I use the slope point form, because this is the slope and this is the point. And my slope point form is y minus y1 is equal to m times x minus x1. So that would be y minus 5 is equal to minus 2 over 3 x minus x1, which is x minus minus 2. And that is y minus 5 is equal to minus 2 over 3 x plus 2. And there we go, guys. That is our equation in slope point form. As you can see, it was a lot faster. So if the question doesn't say in which form you need to write it, then pick the easiest form to write. They've given a graph and then we want to get the equation. First thing, they've given us 2 good points here. Label the points. We have minus 2, comma 3 as the first point, and this one is 1, comma 1. And now we know how to, we have 2 points. We can get the slope by doing y2 minus y1 over x2 minus x1. Or you could have just said, how much over did I go? 1, 2, 3. So the bottom number will be 3. And how much down did I go? 1, 2, which is minus 2. You can double check, you'll get the same answer. So it'll be 1 minus 3 over 1 minus minus 2. That will be minus 2 over 3. Exact same answer. Either or approach is fine. Now, the question just says, write the equation. I don't know the y-intercept. It's tough to see, right? The y-intercept is like kind of in the middle there. So what I should do is write this as a slope point form. Remember the slope point form, y minus y1 equals to m times x minus x1. So pick either one of those points. Let's say I pick this point. So it'll be y minus 1 is equal to minus 2 over 3 x minus 1. There we go. We will first get the slope. We're going 1, 2, 3, 4, 5 over. So at the bottom is 5. And 1, 2, 3, 4 up, 4 over 5. And at the same time, they've also, you can also see what the y-intercept is. That's 4. That means the b value is 4. So now you can say, we can write this equation as mx plus b, which will be 4 over 5x plus 4. Pretty simple. Okay, over here, they're saying find the equation in slope-intercept form, where the slope is given to you as 3, and here's the point. So you will say, okay, y is equal to mx, which is 3x plus b. We need to find the b value now, right? So we have to plug in this number, this point for x and y. Plug in minus 5 for y, and plug in 2 for x. So minus 5 is equal to 6 plus 5. Move the 6 over to the other side. You get minus 11. Plug it back in. Y is equal to 3x minus 11. Okay. They said we have to write this as slope-intercept. B path should be similar. Okay. Whenever they give you 2 points, again, you will get the slope by doing y2 minus y1 over x2 minus x1. And once you get the slope, then we will write the equation as mx plus b and plug in one of the points to get your b value. So now they're saying write an equation of a line which is parallel to this. So the slope of this line is minus 1 over 3. So parallel means the slope of that line will be minus 1 over 3. So if it's mx plus b, that'll be minus 1 over 3x plus b. We need to find the b value. They've given me the x-intercept of minus 3. And we know at the x-intercept, y value is 0. So y value is 0. Sorry, x-intercept is minus 3 and the y value is 0. That's your point. We will plug in that point to get the b value. So plug in 0 for y and plug in -3 for x. 3 and 3 cancels, minus becomes +1, and we will move +1 to the other side, so it becomes -1. So b is equal to -1. Now they're saying write the equation in general form where it passes through these 2 points. We will first find the slope by doing y2 minus y1 over x2 minus x1, which will be 5 minus 3 over -4 minus 2, which is 2 over -6. Move the minus to the top and divide both those numbers by 2. So -1 over 3. Okay, and they're saying in general form, so it's ax plus by plus c. You know what? First, let's write this as a slope point form because that's easier. So that would be y minus y1, pick any point. So let's say 3, y minus 3 is equal to your slope times x minus x1, which is 2 in here. First thing, you're going to cross multiply the 3. So you have 3 times y minus 3 is equal to minus x minus 2. FOIL it. You get 3y minus 9 is equal to minus x minus 2. Move the minus x and minus 2 to the other side. So we get x plus 3y. A minus 9 plus 2 will give you minus 7 is equal to 0. That's what your equation in general form is. So you're going to first write it as a slope point form and then convert it to general form. Now they're saying if it has a slope of this, passes through this, easy. So you say y minus y1 is equal to m times x minus x1. And FOIL it, y minus 6 is equal to 2x minus 6. Move the y over now. So 2x minus y. And you have minus 6, and the minus 6 will go to the other side, become plus 6. That cancels out. So it's just 2x minus y is equal to 0. Simple. Over here, they've given us 2 graphs which intersect at this point. They're saying, what's the solution? Well, wherever they intersect, that is the solution. So x value is 1. What's the y value? 1, 2, 3, 4, 5. So that is 1, 5. Your solution is 1, 5. Simple. Now they're asking us to graph these systems, solve these systems using graphing. So we have to essentially draw each of their graphs and see where they intersect. Isolate this first equation. So we'll isolate the y, move the y over to the other side. It'll be x minus 3. Slope is 1. Y-intercept is minus 3. So y-intercept is minus 3. Slope is 1 means you go 1 over 1 up. So here's the second point. So that line will look something like that. Okay? You'll get that graph. And then you'll isolate the y on the other one. So it'll be y equals to minus 2x plus 6. So that'll be y-intercept of 6. And the slope will be minus 2. So we got to go 1 over and 2 up, 2 down. So that's y-intercept is at 6. 1, 2, 3, 4, 5, 6. And then you go 1 over 2 down. You draw that graph. Wherever they intersect, again, you're going to do it nicely with your ruler. I'm just doing it freely. But wherever they intersect, that will be your solution. Okay? So how do we get the solution? Using graphing, you graph each of those equations separately. And wherever they intersect, that will be your solution. Over here, they're asking us to solve this using substitution. So on the first one, we can isolate our x. And that will be minus 5 minus y. And now we will take that and plug it in for x in the second equation. So in place of x, plug in minus 5 minus y plus 3y equals minus 15. minus y plus 3y is 2y is equal to minus 15. So 2y is minus 15 plus 5, which is minus 10. So y is going to be equal to minus 10 over 2, which is equal to minus 5. Once you have the y value, you can plug it in into this equation to get your x. So x will be minus 5 minus y, which is minus 5. So that's minus 5 plus y, which is 0. So x is 0, y is minus 5. That is your solution using substitution. We've done this quite extensively, so you should be quite comfortable with that. Okay. On the b part, I'll isolate this variable y. So we'll move 4x to the other side, become minus 4x minus 5. And then we're going to take this and substitute that for y into the second equation. So that becomes 2x plus 3y, where y is this. And that is equal to 5. So you get 2x minus 12x minus 15 is equal to 5. 2x minus 12 is minus 10x. Move the minus 15 to the other side. 5 plus 15 is 20. So x is 20 divided by minus 10, which is minus 2. Plug it back in from here to get the y value. That'll be minus 4 times x minus 5. Minus 4 times minus 2 is 8, minus 5, which is 3. So x is minus 2, y is equal to 3. That is your solution. Simple. On C, you will again isolate your y. Just redo the whole steps. Now we got to do this using elimination. Okay, have a look at that. We can eliminate y. We will actually add them. One is minus y, other one is plus y. Minus 3x plus 2x is minus x, and minus y plus y cancels. And 5 plus minus 5 becomes 0. So move the negative to the other side. Negative 0 is just 0. X is 0. To get the y value, you can plug it in into either one of those equations. So let's say you plug it in into the first one. So minus 3 times 0 minus y is equal to 5, which means minus y is equal to 5. Move the negative to the other side. Y is equal to minus 5. So x is 0, y is minus 5. On B part, I realize that the number in front of x's are not the same and the number in front of y's are not the same. But I can make this 4 if I multiply the whole equation by 2, right? Then my x's will become the same. So the first equation will become 4x minus 8y is equal to 26. And the second equation will stay the same. And now to eliminate x's, I will subtract these two equations. 4x minus 4x cancels. Minus 8y minus 5y, that will become minus 8y plus 5y, which is minus 3y, equals to 26 minus 8, which is 18. So divide both sides by minus 3. Y is equal to minus 6. Plug it back in into either one of those two equations to get your x. So 2x minus 4 times y, which is that, is equal to 13. So 2x plus 24 is equal to 13. 2x is 13 minus 24, which is going to be minus 11. And divide both sides by 2. So x is minus 11 over 2. So your solution is minus 11 over 2, comma minus 6. Simple. Next up, they're saying determine how many solutions will this system have. Now, remember those three cases? If the slope is same and the y-intercept is same, you have infinite solutions because it's essentially the same equation. If your slope is same, but y-intercept is different, that would mean you have two parallel lines, so they will never intersect, so you will have no solution. Third one is straight away, if the slope is different, you don't even need to consider the y-intercept. If slope is different, you know they're going to intersect. Infinite means it's exactly the same graph, so they're intersecting at infinite points. This will only have one solution. Those are the three strategies we're going to use. You can clearly see you have a different slope. So straight away, you will have one solution. Because slope is different. You don't even need to do much here. Over here, okay, when you see something like this, then you have to think about the slope. You say, to get the slope, I'll switch the sign in front of x. So -4, divide that by the number in front of y. So that is actually 2. To get the slope of this, switch the sign of the number in front of x. So that'll become 1 and divided by the number in front of y, which is 2. So our slope is the same. Now we have to find the y-intercept. Because, okay, what's the y-intercept of the first one going to be? -0.2, because that's already on the other side, divided by the number in front of y, which is 0.1. And on here, it will be 0.05 divided by the number in front of y, which is also 0.01, right? The y-intercept is different. Slope is same. Y-intercept is different. That means they will be parallel lines. They will never intersect. So you will have no solution for that. Now they've given us these two equations and they're saying, okay, determine if this point is the solution or not. It's very easy. We're going to write down our first equation, which is 2x minus y is equal to -7. Plug in that point. So plug in -2 for x and plug in 3 for y. So that gives me -4 minus 3, which is -7. -7 is equal to -7. So left-hand side is equal to right-hand side. So far, so good. I'm not fully done yet because it has to satisfy both the equations. So far, it has satisfied the first equation. If it's a solution, that means it's a solution to both the equations. It has to satisfy the other equation too. So let's see if it satisfies the other equation. Okay, plug in -2 for x and plug in 3 for y. So -6 plus 3, well, that's -3. -3 is not equal to 7. So it did not satisfy this equation, guys. It had to satisfy both the equations. So I will say this guy is not a solution. Okay, guys, make a note of that. The only time it will be a solution is if it satisfies both the equations. So left-hand side should be equal to right-hand side for both the equations. Only then it will be a solution.